Thank you, everybody, for taking the time. I'm Douglas Fallstrom. I run the product team and operations here at Hammerspace. I'm going to kick today's off with a demo. So last field day, we spent a lot of time announcing the company, the technology, and how things work behind the scenes, a lot of whiteboarding. Today, we're going to do a lot of product. We probably have, I think, 3 or 4 demos scheduled. We're going to kick one off now as long-running demo. We'll check in on it throughout the session, but we also have a couple of more demos as we go through this. So if we're going to switch to the screen, what you see in front of you is our dashboard. It's one of our sites. Up here, you see this site happens to have 200 million files on it. We're going to start replicating this site into the cloud. It runs on-prem in Los Altos, so it's going to take a little bit of time. It's going to replicate up into this site, which is this decrypted name. The replication that we're going to talk about today, which I won't go into details yet, is metadata and data-based. So we're going to switch over to the command line to turn the replication on. Just going to put the parameters in to kick this off. All our demos today are live, by the way. Thank God the internet does not go down, right? Or the Wi-Fi fails.
Good luck.
So you'll see a very uneventful success here momentarily, and the replication is going to kick off. And it's going to run for about an hour and a half, give or take. We'll see. It says success. If you check the share name, what you see is, and this is what David and I will go through in details today, is that sites shares with our participants. And this is really some of the fundamentals behind Hammerspace, how we can make our namespace global. But that's jumping way ahead. I'm going to hand over to David to take you through how everything builds up and how customers are using this as well. So we'll check back in here. The other piece I wanted to do as we're wrapping up is, remember we had that 50 million file thing going? Right, earlier I kicked off in the beginning. Mm-hmm. We went from this site, and I'm not sure if you guys remember, this only had 50 million files when we started, now it's 100. So in the past, probably 30 minutes or so, it actually finished off replicating the 50 million files into the cloud. And that was just starting from a very large amount of files. If you start from scratch, it continually keeps up all the time, and it's maybe a 20, 30-second delay depending on your latencies between sites.
No, as we replicate faster than you can originally create them because it's able to be done with high concurrency.
So on that, we want to wrap up. We talked about this piece. You want to say any final words, David?
Yeah. So I want to wrap up by drawing an analogy here. When you look at the workload or the compute side of the equation, the industry, had a transformative event with VMware abstracting the workload from the server by uprooting the entire OS and everything and putting an OS under the OS, encapsulating it with something pretty heavy, the hypervisor. But that gave us the first level of abstraction and separation of workload. Now we're seeing what I would call phase 2, which is to take it and break it into the smallest constituent pieces, the microservices, and use a very lightweight encapsulation, a container, and then move to a declarative model where through the YAML files you're stating how you want those services to be instantiated on the infrastructure. Because we need to do scale out and because the infrastructure can be very complex with diverse design points, having the system, i.e. Kubernetes, automatically map these smallest constituent workload pieces is incredibly valuable. What I submit to you is that is exactly what we're doing on the data side, breaking it into the smallest constituent pieces and using metadata and lightweight encapsulation. Each of those files is acting independently across the infrastructure to orchestrate data. And for the exact same reason, you need to have the agility, control, and efficiency with the data, almost more so because it is where the value is and where the heft is. It's the stateful part of it. So this isn't about how do we move from stateless microservices to stateful microservices. It's not adding a new type of storage to support Kubernetes environments. That's the last thing this world needs, is another design point specific to Kubernetes, right? And it's not even about how do you plumb persistence to Kubernetes. It's how do we make it possible to move mission critical systems of record into a containerized environment so that those two can have all of the benefit of the orchestration and ultimately move to cloud. So That's, to put a point on it, what Kubernetes does for workload, we're doing for data for the exact same reasons using similar design. Thank you very much for your time.